Alright, how are you guys doing? Today we're going to be doing some word problems with quadratics. Alright, it's actually not as bad as you might be thinking. It's actually really similar to word problems we've already done. It's just except instead of getting linear equations, we're going to have quadratic equations, which we know how to solve now. Right, and we have a lot of ways to solve these quadratic equations, including factoring, completing the square, and the quadratic formula. So you're always free to use whatever method you want, unless they specify a certain method for you to use. All right, so for this warm-up, why don't you guys try setting up a equation for each one of these, and seeing if you're able to do 1 and 2. Alright, so you might want to write a let statement and define all your variables. And so go ahead and pause the video, give that a shot. Alright, so on number 1, Tamara has 2 sisters. One of the sisters is 7 years older than Tamara. The other sister is 3 years younger than Tamara. The product of Tamara's sisters' ages is 24. Write and solve an equation to find Tamara's age. So I'm going to let x equal, well, what do you think I should let x equal? I know one sister is 7 years older than Tamara, and the other sister is 3 years younger than Tamara. So one of these sisters is 7 years older than Tamara. Maybe I should call Tamara's age x, because then I could call this older sister x plus 7. And I can call this younger sister x minus 3, because she's 3 years younger than Tamara. So I'm going to let x equal Tamara's age. And of course you could have used any letter you wanted. So let's use x. The product of Tamara's sisters' ages is 24. Alright, I hope you guys remember what the word product means. Alright, everyone remember that? Product is multiplication. So the product of her 2 sisters' ages. One sister is x plus 7. The younger sister is x minus 3. So the product of their ages will be x plus 7 times x minus 3. Right, and make sure you have them both in parentheses. And the product of their ages is 24. Write and solve an equation to find Tamara's age. So now all I have to do is solve this equation. Well, you might be thinking of teeing it off, right? But we can only do that when it's equal to 0, right? We tee it off using the 0 product property. This is not equal to 0. So what we have to do to solve this equation is get this in standard form, right? And make it equal 0. So I'm going to double distribute, FOIL, whatever you want to call it. We're going to get x squared minus 3x plus 7x minus 21 equals 24. Alright, I'm going to bring this 24 over, minus 24 on both sides. I'm going to combine these two like terms here and get x squared plus 4x minus 45 equals 0. And I think I can solve this now by factoring. What multiplies to negative 45 and adds to 4? Well, I know 9 and 5 seem to work. So let's think of the signs. I think it's x plus 9 and x minus 5 to factor that. Let me make this a little smaller. And teeing it off, we see that Tamara is negative 9 years old, or she is 5 years old. So obviously one of these we're going to need to reject, which is this negative answer. So Tamara is 5 years old. And because I already said let x equals Tamara's age, I can just say x equals 5. Tamara is 5 years old. Make sure you answer the question. This question could have asked how old is the older sister or the younger sister, right? In which case you just plug in 5 for x to get the older sister. The older sister is 12 years old, right? And the younger sister is 5 minus 3, or 2 years old. Right, but they didn't ask that. That is just in case, right? And we do see that the product of the sisters' ages, 12 times 2, is 24. Right, so similar to that, Jeremy and Sam have ages that are consecutive odd integers. All right, do you guys remember consecutive odd integers? Consecutive odd integers are numbers like, I don't know, 7 and 9, 15 and 17. So you'll notice consecutive odd numbers, they always differ, right, by 2. We're increasing by 2 each time. So the product of their ages is 783. Which equation could be used to find Jeremy's age if he is the younger man? So Jeremy and Sam have ages that are consecutive odd integers. Jeremy's age is J. So let J equal Jeremy's age. So if they're consecutive odd integers, that means Sam has to be J plus 2. Right? However old Jeremy is, Sam is going to be 2 years older because they're consecutive odd integers. Right? And we know odd integers increase by 2 each time. So J plus 2 is going to be Sam's age. Alright? So just for example, because we haven't done consecutive numbers in a while, if Jeremy were 5, right, Sam would be 5 plus 2 or 7. If Jeremy were, I don't know, 9, Sam would be 9 plus 2 or 11. So that's how we're going to set up their two ages. And the product of their ages is 783. So Jeremy's age times Sam's age, which is J plus 2, is going to equal 783. I don't see that as an answer choice, so I'm going to distribute. I get J squared plus 2J equals 783. And that looks to be choice B here. All right. Next problem here. A school is building a rectangular soccer field that has an area of 6,000 square yards. The soccer field must be 40 yards longer than its width. Determine algebraically the dimensions of the soccer field in yards. So we got a rectangular soccer field, which means let's draw a rectangle. The area is 6,000. So we know area is length times width. So let's figure out how we can define the length and width. The soccer field must be 40 yards longer than its width. So what's my variable going to be? Am I going to call x the width or the length? Well, I know the soccer field must be 40 yards longer than its width, so let's make the width x, and therefore how long it is has to be the width plus 40, right? Because it's 40 yards longer than its width. So the dimensions of the soccer field then have to be x by x plus 40, right? So if you want some let statements, I'm going to let x equal the width, which would mean x plus 40 is going to equal the length, right? Because the other dimension, again, is 40 yards longer than the width. So we want to make the width x. So the area is 6,000. We just said area is length times width. So, or width times length. I'll do it that way. So we know x times x plus 40 has to equal the area of the soccer field. So we've done plenty of problems like this, except this time when we multiply out, we're going to get a quadratic equation, which we now know how to solve. So we get x squared plus 40x equals 6,000. I'm going to subtract 6,000 from both sides. We get x squared plus 40x equals, x squared plus 40x minus 6,000 equals 0. Alright, so that is a huge number. What the heck multiplies to 6,000 and adds to 40? Well, I can tell you it's 60 and 100, but let's say you did not see that, because you might not see that. So do you guys remember the calculator trick? What you can do on your calculator is to graph y equals 6,000, right, divided by x, and then you can look at the table. Right, so this is a calculator trick we used for factoring a long time ago. Right, you can graph that, and then you can look at table. Look at table. Alright, I'm sorry, I probably should have put a picture of this in earlier, but I would take a picture of my calculator, but whenever I load up the camera, it desyncs the audio once it gets to the video processing. So, right, so if you didn't know how to factor this, you could use the calculator trick, right? You might have to scroll a while, but this would factor to x plus 100 times x minus 60 equals 0. Right, 100 times negative 60 is negative 6,000, and 100 minus 60 is 40. So teeing this off, we get x equals negative 100, x equals 60 when you use the zero product property. Right, we're not going to have negative, what was x? We're not going to have a negative width, so we're going to reject the negative answer, which means our width is 60. But that's not the final answer. It asks for the dimensions. So our width is equal to 60 yards. And our length is 60 plus 40, or 1,000 yards. Sorry, 60 plus 40 is not 1,000. 60 plus 40 is 100. So 60 by 100 yards is the dimension of this rectangular soccer field. Alright, next. A contractor has 48 meters of fencing that he is going to use as a perimeter of a rectangular garden. So again, we got a rectangle. If I add up all four sides of this rectangle, I'm going to get 48. Right, that's the perimeter. Right, that's the amount of fencing we're going to need. We're going to fence that side, that side, that side, that side, and it's going to take 48 meters to do it. So that's the sum of all four sides. The length of one side of the garden is represented by x. Alright, so I'm going to call this x. And I'll call that side x also. And the area of the garden is 108 meters. Determine algebraically the dimensions of the garden in meters. Alright, this is going to be pretty tricky. This is a pretty hard problem. But I know that the sum of all four sides is 48. So what I'm going to do is I'm going to call the other side y first for now. Alright? I'm going to use two variables. So I'm going to say the perimeter is the sum of all four sides, which will be x plus y, or 2x plus 2y. Right? And our perimeter was 48, so 2x plus 2y is going to equal 48. And what I could do now is I could solve for what y is in terms of x. Right? Because we really don't want two variables. So let's figure out what y is equal to. So 2y is equal to 48 minus 2x. I'm trying to solve for y. So y is equal to, I just minus 2x on both sides. Right? Now if I divide everything by 2, I'm going to get y is equal to 24 minus x. So that is what I'm going to replace this y with. 24 minus x. Well, let me write equals 24 minus x. So now I know the area is 108 square meters. So the area, well, that's just length times width. That's x times y. Right, but didn't we solve for y? We said y was 24 minus x, so let's sub that in for y. And so we'll get x times 24 minus x is the area. And we said the area was equal to 108. So there is the equation that I'm going to solve to get the dimensions of the garden. Alright, so that's definitely really tricky. I probably wouldn't give you something like this without some help. Alright, but this is kind of like a system of equations with two variables, right? Because we got these two equations to start. The perimeter is 2x plus 2y, the area is xy, and then you kind of have to solve for one variable in terms of the other. So it's a very tricky problem, but hopefully you followed the steps of what I did. Alright, so we solved for y. We said y was 24 minus x. We plugged that in into our second equation for the area. We said the area was 108. And now solving for this equation, when we distribute, we get 24x minus x squared equals 108. Alright, I want this in standard form, so I'm going to put that negative x squared in front. And then next would come a plus 24x. And then I would subtract 108 from both sides. And there's my equation. Alright, before I try to factor this, I notice I have a negative 1. So you could factor out the negative 1, or I'm going to divide everything by negative 1 to get rid of that negative. Right, it's an equation. I can divide both sides by negative 1. So doing that, that's going to give me x squared minus 24x plus 108 is equal to 0. So now we think what multiplies to 108 and adds to negative 24. And again, if you have trouble with this, which I suspect a lot of people would have, use the calculator trick, right? Graph in your calculator y equals 108 divided by x, and then look at the table, right? When you look at the table, it's going to give you all the things that multiply to 108. So I think it's 3 and 36, 4 and 27 work. Alright, I'm just going to skip to the answer. I believe the two numbers that multiply to 108 and add to 24 are, I just had it, 18 and 6, right? It's going to be 6 and 18. So this will factor to x minus 6 and x minus 18 equals 0, which means x could be 6 or x could be 18. Oh, so those both look like good answers. So let's see what happens when I try plugging in these answers. So if x were 6, well then y would be 24 minus 6, right? And that would be 18. So the dimensions of the garden would be 6 meters by 8 meters, right? I can't reject either answer because they both look good. So if x were 6, I'd have 6 by 18. Well, what would happen if x were 18? If x were 18, well, then this would be 18, and y would be 24 minus 18, which is 6. So it doesn't matter how we do it. Either way, we're going to get 6 by 18 meters. So it's going to be 6 meters by 18 meters. Are the dimensions of what we're looking for of this rectangular garden. Alright? So let's say we went with the x equals 6 answer. Y would be 24 minus 6, which is 18. Those are our dimensions, 6 by 18. Alright, so your homework, you're going to have something similar, but not quite as tricky. Alright, but still, if this one made sense, I think you can do problems similar to that one. So this last one, just want to review using a graphing calculator again. So using your calculator, sketch the function on the axes provided. So just a sketch. You might need to zoom out or extend your window. So I did take some pictures of this one. So that one looks like, why are all my pictures upside down? That's kind of annoying. But hopefully this doesn't, can I rotate this? There we go. Alright, so when you go to graph this in your graphing calculator, you're not going to see too much of it. You're just going to see pretty much nothing. Cancel. Undo. Alright, what you're going to see is pretty much just this line going straight up like that. Right, and that's because this graph goes up really high and then it comes back down and you can't really see all of it. So I would just recommend looking at the table and using that to get a sense of how high it's going. Alright, otherwise you can adjust the window, but we haven't really talked to it. But I can talk you through the steps a little. If you go to menu and you go to choice 4, which is window, and you go to window settings, you'll see a X min value and a X max value. So right now on your graph it goes from -10 to +10. So if the scale they're giving us here is up to 15, you want to change that X max to at least 15. So I'd probably change the X max to, I don't know, at least 20. And I also changed the maximum Y value to at least 75. I probably changed it to 100. So let me just show you what that might look like if you adjusted the window. All my pictures are upside down, so it should look something like this if you adjust the window. Alright, so that again was menu, choice 4, window settings, choice 1, and then you can change it to these numbers. Alright, you can change the maximum X value to 20 and the maximum Y value to 100. And then what your graph should look like is photo library. Something like that. Alright, so you can see everything a lot better. And then if you go to menu, again, after you do this, if you go to menu and then analyze graph, right, you can use those features to find the maximum and the zeros, which we've done before in class. Alright, you get the lower bound, upper bound, lower bound, upper bound for the 0. Right, and you can find the maximum or the vertex and the 0. So the graph is going to look something like that. And again, that was a lot, and it's really hard to do this without showing you on the calculator physically. It's hard to write steps for this. But yeah, that's how you can get a good sketch on your graphing calculator. And it's going to look something like that. Alright, I don't think we're going to go into the negatives, so let's just make it look something like this. Alright, so again, the flow rate of oil in a pipe in gallons per hour. So this y-axis, I know this one's a little weird, this is flow rate, or how fast oil is flowing in a pipe. It's modeled by that function where t is number of hours elapsed. So t, that's number of hours that's passed. So we sketched it using our calculator. If you didn't like sketching it using a calculator, we'll get the points without a calculator, and then we can plot those in. Or again, just hit Control T and actually think I'm going to do it that way. I'm just going to plot points. So like 0, comma 11 was a point, so maybe that's over there, right? 1, comma 29. And you notice it maxes out at 5, comma 61. If you look at the table, right, that looks to be the vertex. And it reaches 0 in between 10 and 11. So the 0 is something like 10 point something. So just with a couple points, you can make a good sketch of the graph. All right, but it says algebraically find the time when the flow stops when the flow is 0 to the nearest tenth of an hour. So if we're looking for when flow rate is 0, well, that's f of t, that's the y-axis. So we're going to make f of t, the flow rate, equal to 0 and solve for t. So 0 equals negative 2t squared plus 20t plus 11. Right? So it's the same kind of work we've been doing with like drawing a ball off a building and stuff like that. It's just the context is a little different. This one is how fast oil is flowing through a pipe, which is a little weird. Anyway, if we want to solve this equation, it does tell us that we're going to be rounding to the nearest tenth of an hour. So this is probably not factorable, and it is not. So that means we have two methods. We can use completing the square or quadratic formula. So I don't know which one you guys like better, but doesn't matter which one we use. I think I'll use quadratic formula. So x equals negative b. So that's our b value here is 20, right? So negative 20 over 2a. So 2 times our a value is negative 2 there, plus or minus the square root of b squared. So that's 20 squared, put the 20 in parentheses, b squared minus 4. Our a value was negative 2 minus 4ac, all over 2 times a value negative 2. Alright? I think this is still new enough that I'll write out the full formula. Alright, b squared minus 4ac, all over 2a. And again, all I did is I plugged in for a, b, and c, right, for my equation. So x equals negative 20 over negative 4 plus or minus the square root of 400 and then 4 times 2 times 11. And I notice I have two negatives, right? Negative 4 times negative 2 is positive 8 times 11 is 88. So 400 plus 88 divided by negative 4. So x equals 5 plus or minus the square root of 488 divided by negative 4. And I wouldn't expect you to simplify that radical, right? So we can just type in this into our calculator and see what we get, since we want to the nearest tenth. So x could either equal 5 plus the square root of 488 divided by negative 4, or x could equal 5 minus the square root of 488 divided by negative 4. So type both of those into your calculator, and let's see what we are getting. So 5 plus square root of 488 divided by negative 4. I'm getting a negative answer there, right? So that's going to be a negative time. So I don't like this answer, so I'm going to reject it. It's around negative 0.5. And my other answer is going to be 10.5. Around 10.5. Right? I'm rounding. Right, I'm actually getting 10.52268505086 something something something. But rounding to the nearest tenth, the flow rate is 0 after 10.5 hours. Alright, so 10.5 hours. write f of t in vertex form by completing the square. Alright, so I probably could have saved time by completing the square over here because the steps are going to be similar. Alright, but let's do it now. So f of t equals negative 2t squared plus 20t plus 11. So we're not solving for the zeros, so we leave the f of t. F of t is not equal to 0. We just want to write f of t in a different form, in vertex form. Right, and again, the way we do that is by completing the square. So we're going to move the 11 over to the other side. So f of t minus 11 equals negative 2t squared plus 20t. And remember, before you can complete the square, this coefficient always has to be 1. So we're going to factor out that negative 2. So taking out a negative 2 from 20, that's going to become minus 10t. And to complete the square, well, we're going to be adding 25 here, right? Half of negative 10 squared. But what are we really adding? We're really adding negative 2 times 25. So on the left side, this will be minus 50. And then we get f of t minus 61 equals negative 2. When we factor this, right, it's going to be t minus 5 times t minus 5, or t minus 5 squared. Again, just half of negative 10 there. And here's our function. The flow rate of oil in this pipe is equal to negative 2 times t minus 5 squared plus 61. So the vertex, right, 5, 61. And we got it in vertex form over here. Very cool. Now look, that matched what I saw in my calculator when I looked at the table. So we did the first two parts. We found the vertex by completing the square, and then we stated the vertex of a function. Last is write a sentence explaining what the vertex means in this context. So this is x, that's y. So let's take a look at our axes again, and let's see what that means. So it means after 5, well, 5 what? After 5 hours, right? The flow rate was at a maximum of 61, what are the units? 61 gallons per an hour. Alright, so that 5, 61 means after 5 hours, the flow rate is at a max of 61 gallons per an hour. Alright, so I know the context here again is a little weird. It's a lot easier thinking of time and its height, right, or something like that. But in this case, we got hours and the flow rate, or how fast oil is flowing through a pipe. It's modeled by a quadratic function for some reason. So we do it the same way we do any quadratic modeling problem. Alright. This one was also a little more difficult because our zeros were irrational, so we had to round them. So that's going to be it for today. So we're going to practice with some word problems for homework. Most important part again is the setup. Alright, think about your let statements. And if you have any questions, as always, let me know. Alright, I hope you guys had a good weekend. Spent some time with your family. I hope you and your family, you guys are doing alright. Alright, so see you guys next time, and take care.